guys, in this video we will talk about clustering, and in particular we will go over the hierarchical clustering. So let's get to it. Hierarchical clustering basically is another algorithm or another technique, if you want to call it that way, that you may consider to cluster your data. Okay, so keep in mind that clustering is an unsupervised learning technique, and basically the goal is to find groups in your data. Okay, so this is just a follow-up from the previous tutorial. In the previous tutorial, we'll talk about k-means and how to apply k-means to the iris dataset. So in this tutorial, we will talk about hierarchical clustering and how to use it as a clustering mechanism on the iris dataset. By far, the big advantage of using hierarchical clustering over k-means is that you don't need to specify how many groups you want to group your data into, and that was one of the big disadvantages of k-means. So then one of the first things that you need to set up when it comes to k-means is how many groups you need to consider for your data. So in this case, basically you don't need to specify how many groups. So basically you're going to let the data speak for itself. Another cool thing about hierarchical clustering is that you can get a chart out of your clustering, okay, and that is called a dendrogram. Okay, dendrogram. So a dendrogram looks basically like a decision tree. Okay, so let me quickly show you what I mean by a dendrogram. So if we quickly Google dendrogram, and then we click on images, so this is what a dendrogram looks like this one here, or this one here, or this one here. Okay, so if you are considering hierarchical clustering as a technique to cluster your data, you can visualize it with a dendrogram. Okay, in this tutorial we will talk the details about how a dendrogram is constructed. Okay, so let's go back to the notes. All right, so a dendrogram basically is what is called an agglomerative clustering algorithm. Basically is a bottom top approach. So what that means is that at the very bottom, every single observation is its own cluster, and at the very bottom, every observation is its own cluster, and then as you keep moving up on that dendrogram, or if you want to call it the tree, so as you're moving up, so then you start grouping observations based on similarities. Okay, and in this case, similarity is also going to rely on the Euclidean distance, but it's not going to be just the Euclidean distance by itself. Okay, and just give me a couple of seconds and I will explain what I mean by that. Okay, so the big idea of the dendrogram is at the very bottom, every single observation is its own cluster, and then as you keep moving up on the dendrogram, so you start grouping observations that they are similar to each other, and then eventually when you get to the top of the dendrogram, every observation belongs to one cluster. So then the top of the dendrogram and the bottom of the dendrogram, there are two extremes, right? At the top, every observation belongs to the same group. At the bottom, every observation is its own group. Okay, now here is all the details associated to the agglomerative clustering algorithm and how you can use it to construct the dendrogram. Okay, so that's basically what I just explained. What I want to emphasize here is the following, right? So then something that is very important when it comes to constructing the dendrogram is the idea of similarity, okay? So in the previous tutorial, we talked about the k-means, and we know that k-means groups two observations depending on how close they are to each other, right? And then in order to measure closeness, so we rely on the Euclidean distance. In this case, the idea at the very beginning is simple, right? Every single observation is its own cluster, but then as you keep moving up, and then you start grouping observations based on similarity, you will come to a point that you have one group that has, for example, 2 observations, and then another group that has 3 observations. And then at that point, how do you decide or how you quantify similarity in that case? So that's what I want to emphasize here. So then that's where the idea of linkage comes to the picture. So let me quickly summarize that idea as follows. So then, for example, here you may have one cluster, right? Let's say this is cluster 1, and then here you have cluster 2. Okay, and cluster 1 has 2 observations. Let's say that's those 2 observations, and here you have 3 observations. Now the question is, how do you find, or how do you compute the similarity between those 2 clusters? Okay, so we're still going to rely on the Euclidean distance, but it's going to be slightly different. So for example, so in this case we have 2 observations in one cluster and 3 observations in the other cluster. So then technically speaking, we need to compute 6 Euclidean distances. Okay, so let's visualize that as follows. So let's say this is the first Euclidean distance. Let's call it D1. Then this is D2, and let's assume that those are straight lines. Okay, and here we have D3. Okay, and then here we have between this and this one, this is D3, D4. Then here we have D5, and then here we have these 6. Okay, so those are the 6 distances. Okay, now how are we going to compute, or how are we going to quantify the similarity between those 2 clusters? That's where the idea of linkage comes to the picture, because again, keep in mind that as you keep moving up from the bottom to the top of the dendrogram, you're going to start grouping observations. Okay, and then how you're going to start grouping observations or grouping clusters of observations is going to depend on the similarity. Okay, if 2 groups are similar to each other, they're going to get grouped together. So we have the first type of linkage is called the complete linkage. Okay, and the complete linkage is going to be the following. So the complete linkage is going to be just after you compute, or after the algorithm computes the 6 distances between those 2 clusters, is going to be the maximum of those 6. So is the maximum of D1, D2, D3, D4, D5, and D6. So that will be the complete linkage. Then we have the next one is the single linkage, and that basically what it is the opposite of the complete. So let me write this clear. Single linkage. So that will be the minimum of D1, D2, D3, D4, D5, and D6. Okay, and then the average linkage, as the name suggests, is just going to be the average of those 6 distances. So it's going to be D1 plus D2 plus D3 plus D4 plus D5 plus D6 divided by 6. And then we also have the centroid linkage, which basically what it is just, it's slightly different from the previous 3. So the centroid linkage is, it looks at cluster 1 and it computes the centroid of cluster 1. And then it looks at cluster 2, it computes the centroid of cluster 2. and then once you have those two centroids, it computes the distance between those two. Okay, and that will be the centroid linkage. Okay, now based on my experience, complete and average, complete linkage and the average linkage, those are the most common linkage that I seen used by practitioners. Okay, but that's basically what hierarchical clustering is. Okay, it's just, again, it's just another technique that allows you to cluster your data. Okay, we still rely on the Euclidean distance, but we use the Euclidean distance in a slightly different way using these linkage concepts. The big advantage over k-means is that we don't need to specify how many groups we want. Okay, we pretty much, we're going to let the data speak for itself, and then we can visualize it with the dendrogram. Okay, all right, so that's basically another approach, another technique that you may want to consider if you're thinking about finding groups in your data. Now let's get to see the dendrogram in action. All right, so we're going to continue using the iris dataset. But now we're going to use the dendrogram approach to cluster the data. So here, this is just the same code that I used in the previous tutorial, just to read the data into the Jupyter notebook using pandas. Okay. First, what we're going to do is we're going to define what are the features that we're going to use for clustering purposes, and then we're going to standardize the data. And that's something that I emphasized in the previous tutorial. Anytime that you are relying on an algorithm that relies on the Euclidean distance, make sure that all of the input data are on the same scale. So then that way you don't end up with biased results. So let's start by loading the standard scalar. Again, that's a very popular one. So defining the scalar. So scalar that, and then here is defining the data, columns to scale. So in our case, we're gonna call it X, and it's gonna be df, and we are dropping the column species. Okay, and then after that, we're going to transform the data, and then I'm gonna call it X scale. It's gonna be a scalar p transform X. Okay, so up to that point, so it's supposed to be uppercase X. So up to that point, we define the data, we standardize the columns. Now we're ready to create the dendrogram. Okay, so for that, we're going to be using the library called SciPy. Okay, SciPy is another library that we can that is used for scientific. Sci stands for scientific, Pi stands for Python, so it's for scientific Python. Okay, it has a bunch of different numerical algorithms that you can use. Okay, so it's another of those popular Python libraries that you may want to be familiar with, especially if you are in the data science, machine learning, and AI space. Okay, so let's start loading what we're going to loading the functions that we're going to use from SciPy. So this is the library. So SciPy is the main library, so cluster is the sub library, and then we're loading hierarchy from there. So we're going to use dendrogram and linkage. The linkage is going to be what we use to compute similarities among clusters of observations in general, and dendrogram is going to be the function that we will use to visualize the results in some sense. Okay, All right, so here is performing hierarchical clustering. So then I'm going to say HC. I always use HC for hierarchical clustering. Linkage. So notice that here you need to pass the standardized data. Here is using another method, word. So then let's use in our case. Let's start with let's use the complete. Okay, complete. The method is complete and metric Euclidean. And then after that, so that's gonna compute the linkage, and then we need to visualize the result. So let's load matplotlib just for visualization purposes. Okay, so it's gonna be dendrogram. Okay, no, I don't want any of these. Let's use just default values. And then after that, let's add some titles, sample index distance. Okay. All right, so here is the dendrogram that we get out of the iris dataset. Okay. So again, at the bottom, every single observation, it's its own cluster. And then as we keep moving up, you can see that some of those observations and some of those group of observations, they get fused together. And then eventually at the top, every single observation belongs to one cluster. Okay. Now, one thing that I want to emphasize here is that I didn't specify how many groups I want. So as you can see in the code, I didn't specify anywhere I want 3 groups, 4 groups, 5 groups, whatever the case may be. Okay, so here we are just letting the data speak for itself. Okay, and typically one of the common applications of hierarchical clustering and the dendrogram in general is practitioners visualize the data, or they cluster the data in this fashion. They look at the dendrogram, and based on what they see in the dendrogram, they can say, okay, I can see 3 groups, or I can see 4 groups or 5 groups, whatever the case may be, and they use that as a they use that number of group in the k-means algorithm. So then here you can see, okay, maybe there are 3 groups, and you can use that information to run your k-means algorithm. Okay, now what will happen, notice that the dendrogram, it changed a little bit depending on the method. So then here I'm using complete. Let's change this to average, and then the results may look different, right? So then if I do simple, oh, they don't have the method simple. Okay, so but yeah, so you can see that the results change, right? So here's another method called word, but in my case, again, or based on my experience, what I seen that is used a lot is complete or average. Okay, and they tend to generate pretty much stable results in some sense. Okay, so that's hierarchical clustering, and that is the dendrogram. Okay, again, so this is another of those techniques that you can use to cluster your data, but it's more on the exploratory side of things. And typically, again, the big advantage of dendrogram and hierarchical clustering in general is a data-driven technique. You don't need to specify the number of clusters, and you can use the results that you see from the dendrogram as a way to specify the number of clusters in your k-means algorithm. Okay, all right, that's all I have on this video. See you on the next one.